So we need to decide if this is a perpendicular bisector XF. So first of all, I'm going to just go ahead and draw in my triangle. So to draw in my triangle, I'll plot my points, and then I'll go ahead and, oops, that's not working like I wanted it to. Just a second here, I'll draw in my triangle in just a bit. So I have my triangle drawn in. Now, we are told that x is the midpoint here. So we need to find x. So we need to do our midpoint formula. So, and we need to do our midpoint formula for AD. So we have A, we have D. So x is the midpoint. So we need to go ahead and add together our two values of x. 2 plus 12 divided by 2. Then we also need to add together our two y values of our points. 10 plus 8 divided by 2. So in other words, we get x to be the point. We add together the red, we get 14 over 7, for 14 over 2, which is 7. We add together the blue, we get 18 divided by 2, we get 9. So x is 7 over and 9 up, which is right here, which it does end up being on that line, which is good, because it's supposed to be the midpoint, and you can see it does appear to be about halfway. Now, to decide if it's a perpendicular bisector, well, we just, since it's a midpoint, we know it's a bisector. So we now have to decide, is it perpendicular? So I can take my, come on, hey, it works when I'm not recording. Why doesn't it work when I am recording? Okay, we'll draw that in, and we'll have our x. I'll write that in. We need to know if it's perpendicular. Well, if it's perpendicular, one of the ways we can do that is to look at slopes. So we can look at the slope of AD and then we can look at the slope of FX. So remember, slope is rise over run. So we can take the y of our A minus the y of our D divided by the x of our A minus the x of our D. Subtract the top, we get 2. Subtract the bottom, we get negative 10. And then we get negative 1 over 5. Now we can do the same type of thing for our 2 points for f and x. So we can subtract our y of the x minus our y of the f over our x of the x coordinate of the x point minus our x coordinate of f. On top we get 5, on the bottom we get 1. So since our two slopes, which are these two right here, are opposite reciprocals, since they are opposite reciprocals, we know they are perpendicular. If these two slopes that I circled here were not opposite reciprocals, it would not be perpendicular, and we would not be able to prove this. So, since we know that x was the midpoint, it's then the bisector, we just looked at slopes to do the perpendicular. So since we've done both, we can then conclude that fx is the perpendicular bisector. Down here, we want to go ahead and prove this. Whenever you're doing a proof, Your first line will always be your given, what you're starting out with. And the last statement that you're trying to will have on the left side in the statement column will always be what you're trying to prove. All you have to do is fill in the in-between steps and give reasons why you're doing that. So we are told that 2 and 3 are the same. So I'm going to mark that. And we're told that we are parallel. And that's indicated here with these arrows. Now, we can't really make any conclusions about the 2 and the 3, but we do have parallel lines. If we have parallel lines, we know that if our parallel lines, which are here and here, are cut by transversal, that would be like this one right here. So if we have our parallel lines cut by transversal, we know that we have some angles that are going to be the same. We know alternate interior angles are going to be the same, corresponding angles, and so on. Now, for our particular problem, the angles that we're looking at, we would know that this angle here would have to be the same as this angle down here, because 1 and 2 are corresponding angles. So we can say angle 1 is the same as angle 2. And our reason is we started out with parallel lines, so parallel lines implies that our corresponding angles are equal. So to try to finish this, we already know that angles 1 and 2 are the same, and 2 and 3 are the same, and 1 and 2 are the same. So therefore, we should be able to go ahead and replace our angle 2 right here with angle 3 from what we have up here. And when we do that, we would get this here, and when we just substitute that in, that's substitution.